All right. Dusty, don't say anything crazy. You're on video now. Okay, so is there any other equation? Peter? Oh, what about V bar equals D over T? Maybe. Now at this point, I want everyone in the room slowly to do exactly what we're doing up here. Don't go ahead, do it on your own. Don't pick one and say, I got it already, and keep it moving. Slowly, that's why there's only 4 problems on 2 pages, for us to really flesh this out carefully. So here we are. Now, let's move along. Let's actually try to set these up. We're solving for time. Let's first do equation 1. If we substitute in, you could rearrange it first if you want, it doesn't matter. But if we substitute in, we have VF is 15 equals VI is 15 plus, what's the acceleration? You must use the x column. The acceleration is 0 times t. What happens with the 0 times t? Gone. Don't even waste time thinking about it. Huh. Okay, let's leave that alone for a moment. Let's try number 2. Let's substitute this one. This one actually is already set. Oh no, actually it's not. D equals, my mistake, replace that with 25 equals VI 15 times T plus 1/2. Acceleration is 0 times T squared. What happens to this whole term? Gone. Multiply by 0, the whole term's gone. Nothing remains. And then we come to choice 3. This is an interesting one. Do we know V bar? So no one needs to be solving those right now. You need to be doing number 3 with us. Do we know V bar? Can we know V bar?
Yes.
If it's starting at 15, it's ending at 15, there's no acceleration. What's the average?
15.
You got a 15 on your first quiz, 15 on your second quiz. Average? 15. The V bar is 15. Where could you run them up? Where can you have some trouble? Very simple. V bar is 15. We could put a 15. But notice, did you have it in your list up here? You're free to add it to your list. But just in case you did not add it to your list, nowhere have you written V bar equals 15 meters per second. So you better make sure that this 15 has a meters per second somewhere. Whether it's here or whether you add it to your givens list, it better go somewhere. So 15 equals, D is 25 over T. Okay, so we have all 3 of these. If you did number 2 or 3, will you get the answer? 1 2/3, 1.7 seconds. You see that? Sure, solve for T. 25 divide 15. Or here, you have to cross multiply. 25 divide 15. You should get what I have written up top. 1 2/3 or 2 sig figs, 1.7 seconds. What if you chose equation 1?
Note 3.
There you go. Reading is fundamental. Will this ever happen to you as an individual in this room? Will you ever get a problem where you're left with 15 equals 15? Or maybe minus on both sides, 0 equals 0? Most likely, yes. When that happens, is it time to give up and go to another problem? No. If you solve and you find whether it's 15 equals 15 or 0 equals 0, it's true, but you're not any smarter. If that happens, switch. Use a different equation. Or you might even have to use a different column. So if that ever happens, just redo it with a different equation or a different column. This, I'll tell you straight away, it's not going to happen in an unpredictable way. If you use VI and VF from the X column in an equation, it's going to happen. That will automatically happen. So you can have your warning, or you can just realize, oh, wait a minute, don't give up. I just picked the wrong equation. Let me pick a different one. So this won't be the one you use to solve it. You'll just jump to one of the others. Okay, so the notes here, they all pertain. This one, this note actually goes with equation 1. And then this note, since acceleration in the x is 0, you can use V bar as d over t. This note actually goes with our third equation. So all these different scenarios, there they are. All right, you ready for 24? Let's go. How high is the cliff? Now, the mistake people make is they read, how high is the cliff? The problem must be y direction only. Yeah, they may jump right to an equation. I know it's y direction only. I don't have to worry about anything. I just jump straight to the y givens. Sometimes that gets you in trouble. So really the question is, back up. Is it a curved trajectory? No matter what the question is asking, is this a curved trajectory? Yes? Okay, then make the chart. X, Y, R. And believe me, do you have to redo your givens? Yes, absolutely. Do them again. Practice them. All right, you ready? Nick, you're up first. Okay, how about in the y direction? Okay, 9.8 meters per second. Extra quiet just for the camera, huh? All right, since it's a drop problem, let's call down positive, and the resultant, of course? There you go, 9.81 again. All right, good. Do not copy these from your upper chart. What you need right now is practice getting them from your brain and your thoughts. So don't go back and copy. Think. Okay, we just ran through the accelerations. What's the next given we may know about? Which velocity?
Starting.
Sure, starting. VI. What is the VI in the x?
15.
15. And in the y, it's a drop problem, so it'll always be
0.
okay. And of course, the resultant then is
15.
15. All right, we're getting somewhere. Next, what else do we know? Yeah, we know the distance in the x direction, the d at the end, is 25 meters. What else do we know?
Time.
The time for all of them is 1.7 seconds.
Okay, we can put that here. We know, I'm going to leave a little space. T at the end is 1.7 seconds. T at the end is 1.7 seconds. Now, I'm deliberately leaving it off the resultant column. Some of you might write in, I'm leaving it off. You'll see why in the next question. Is there anything else we know? Yeah, so the VF and the X over here is also 15. All right, great. We got all this good stuff, including the time we added from the last problem. Of course, we are missing question mark. Right? What is it?
D and in the y column is
Yeah. You want to find for how high is the cliff. Effectively, you can say, what is the height? That's what I want. But really, what are you going to have to solve for from our equations? D in the y direction is really what you're solving for. Well, you just write it as D. We're in the y column. So we want the total. That's our question mark. Now, as before, which column will you use because you cannot mix? The x, the y, what are you going to use? Of course. Can you use the x column if the question mark is in the y column? It's not going to solve it for you. The y column is what you want. We pick an equation. This one's pretty straightforward. Kate, what's the equation going to be? Yeah, all you should look. Don't trust your memory. Some of you are doing the D because of all that business and you forget about the square or some other business. Just check. Go ahead. Okay. VIT plus 1/2 AT squared. That suits our givens nicely. And then when you substitute, D equals VI is 0 in the in the y column, 0 in the y column, times 1.7. Immediately what happens to this whole term?
Cancels.
Out. Plus 1/2 The acceleration we found to be 9.81, and the time is 1.7 again. T is squared, don't forget the square. And if you do this, you should get the height of the cliff. We're actually getting here distance in the end, which is then equivalent to the height of the cliff. So run your numbers real quick. Did you get 14 meters? Good? All right. All right. I know it's tough. You can do it. Madeline, you can do it. Next page. Now, what is the speed of the car as it reaches the ground? Is anyone trying to answer that question in their head immediately? Don't. That is not a question you look, read, and answer. This is a problem where you go back and say, is it a curved trajectory? Yes or no? Silvio, yes or no? Yes, it is. Curved? Yes. So make the chart. X, Y, R. And this is a good one. I like this one here. It's question 25. Let's start slapping our givers in there right quick. All right, what do we got? Go ahead, Melissa.
BI is 15.
Yep. VI in which direction?
The X.
Okay. In fact, I'm a big fan of doing the accelerations first,
Okay.
because that's not problem dependent. This one depends on the problem. I would run through these accelerations immediately. Accelerations in the X 0, in the Y 9.81, resultant of those two 9.81. VI in the X, yes, is 15. VI in the Y, 0. And resultant VI, 15 and 0 gives you 15. Okay, we also knew the displacement in the end for the X is 25. We actually now know the displacement in the end for the Y is 14. We don't know the resultant displacement. We know the VF for the X is 15. And we know the time at the end is 1.7 seconds. Now, I'm going to write this one over here in black because I do not recommend you do this one. It's a different color. You may actually find yourself doing this. You may find yourself putting the time in the resultant column. I don't recommend you do it, but you may. And so we're going to set up why that's an important one to avoid. What's this question asking for?
The speed as it reaches the ground.
Which speed?
The
Is that the X, the Y, or the resultant? It doesn't say, which means it's the result. Yes, so it's the VF, and it is specifically in the resultant column. This is the question. And so, I'm going to warn you. Can you use the resultant column to solve this? The answer is, and there's no reason for you really to know, the answer is N-O, no. This note over here, do not use the R column with the equations on PRT 6. That's for this business right here. These are one-dimensional equations. They work for the X, they work for the Y. They don't work for the combination of the two. So you'll get a number, but it won't be correct. So if you can't use the resultant column here, you can't do. In fact, I'm going to cross off this T. You can't use it there. How could you figure out that VF? This is a nice little pump your feet question. How could you figure out that VF? There's another way. There's another way. We just did W42. There's another way. We did notes page 5. There's another way. Oh, you thinking it?
Pythagorean theorem.
Oh, so if the trajectory is here, and they want to know about your resultant velocity, couldn't you get that if you knew the vertical and the horizontal? So what are you actually going to have to do here?
Pythagorean theorem.
You can't do it yet.
Oh.
What are you actually going to have to do here before you can do Pythagorean theorem. That's where you do Pythagorean. What are you going to have to find first?
Oh, VF of the
VF and the Y. Yes. So let's stop there. I'm going to finish doing this as soon as you leave.